Alright, in this video we're going to be talking about how to model and solve one variable, one-step equations and inequalities that represent problems including geometric concepts. Alright, our first problem. So, Holly bought a magazine subscription for a year. She paid $27. Holly wanted to find the price, P, of the subscription each month. She created the model shown to help find this price. What was the price of the subscription each month? So notice she has $27 and it's for the year, so she divided it into 12 different equal portions. And she wants to find out how much it's going to cost for each month. On this, obviously, we took something larger and we divided it into sections, so obviously this is a division problem. So what we're going to do, two ways we could do it. I'm going to divide 27 by 12 because there's 12 p's. But we'll get back to that in a second. In middle school, it's important, obviously it's important in elementary, but it's important that we start to think about things algebraically. So on this one, how many p's do I have? I have 12 p's. And how much is the subscription? She paid $27, so 12 times p will equal 27. I could add p up 12 times, but the easier way is 12p equals 27. Once we have an equation set up, we can solve it. I need to isolate the p. So what am I doing to the p? I'm multiplying by 12. What's the inverse? The opposite of multiplying by 12, it's dividing by 12. Why is that? Because 12 divided by 12 equals 1, and 1 times anything, the identity property, is p. Now, in the equation, we need to keep it balanced, so if I divide by 12 on the left side, I need to divide by 12 on the right side. And then we get back to this, which is the division problem we set up. So we're going to divide 27 by 12. 12 goes in the box, 12 outside, divisor. So what we need to keep in mind, look at our answer choices. Our answer choices are kind of random and all over the place. Now we can do this without actually dividing because I know 12 times 2 is 24. I know 12 times 3 is 36, and 27 is in between it. I know my answer must be in between 2 and 3. Obviously the only option that would leave me is G. Let's prove it. I'm going to erase some of this. So I'm going to have 27 divided by 12. 12 won't go into 2. We'll go into 27 2 times. 2 times 12 is 24. Subtract, and we get a 3. I have a remainder, so what do? Well, I'm doing a different color. I have to add a decimal. Because once I've added the decimal, I can add a 0. And so, because if I add a 0 to the right of the decimal, it doesn't change the value of the number. 12 will go into 30 2 times. 2 times 12 is 24. Subtract. We get 6. We're going to add another 0. Bring it down. 60. How many times will 12 go into 60? That's right. 5 times. No remainder. We're done. So again, G is our answer. Next problem. A student needs to collect at least 10 flowers for a science project. The student has already collected 3 flowers. The inequality shown can be used to find n, the number of flowers the student still needs. So we have the inequality n plus 3 is greater than or equal to 10. Which inequalities represents the solution, which is the answer, set for this situation? Now since it's an inequality, there's not just one answer. It's not like the answer could be 4, but there's an infinite amount of responses that could be satisfy this inequality. And we'll talk about that in a second. So first I'm going to write this a little bigger so we can see it. N plus 3 is greater than or equal to 10. So I need to isolate the variable. So what am I doing to the n? I'm adding 3. The inverse of adding 3 is subtracting 3. That cancels out, zeroes out. And we need to keep it balanced. And whatever I'm doing to the left side, I do to the right side. And so that leaves me n and a 7. And I keep the inequality facing in the same direction because I did not multiply or divide by a negative number. So let's read that. You always read the variable first, whether it's this, and let me show you, I could write it as such. These both are equivalent. Okay, why? Because on the right, n is greater than or equal to 7. which means the answer could be 7 or any number greater than 7. On the left, you read the variable first, n, and it's still greater than or equal to 7, so they are both equivalent. So let's look at our answers. Obviously, it's not F or G, because 13 and 7, not the same. And then you have H and J, they both have 7, but you have to pay attention to the inequality. And so the inequality, the answer would be J. So, because again, n is greater than or equal to 7. So, let's go back to the original problem. You need to collect at least 10. And when you see at least, that means it could be 10 or it could be a million. Obviously, you probably wouldn't collect a million flowers. That would be a lot and take a long time. But you need to collect at least 10. You already have 3, so how many more do you need? So obviously 7 to meet your goal, but then if you really enjoyed them or they're really pretty flowers, you could collect more. So J makes sense because again, it has to be 7 or greater. All right. The sum of the measures of two angles is 183.6 degrees. One angle has a measure of 54 degrees. What is M? The measure of degrees of the second angle. So let's just say, oh, that's not good enough. Now I have an angle, 54 degrees. No, that's definitely not 54 degrees angle, but work with me here. Let's just say it is. And then I have an unknown angle. But I know both of those combined are 183.6 degrees. So how would we solve this? Again, in equations and in middle school, we need to learn to think algebraically. To solve this, I have one angle, I have another angle, and I know they both angles equal this. So I am just looking for the unknown value right now. So what am I doing to the m? Currently I'm adding 54, and the inverse, the opposite of that, would be to subtract 54, because that zeroes out. Keep the equation balanced. Whatever I do to the left side, I do to the right side, and I get that, which kind of makes sense. That's an obtuse angle. That, I don't know where they got that. This is definitely not obtuse, and that is greater than obtuse. So our answer is A, as in apple, and I'm just adding up two angles. They equal that. Solve it algebraically, and you're done. All right. Well, I guess that's the last video on this, or last slide. So again, in this video, we talked about modeling and solving one variable, one-step equations and inequalities that represent problems including geometric concepts. So don't forget the inverse. So we need to isolate that variable. We got to keep our inequalities and equations balanced. So don't forget, whatever you do to one side, you do to the other. Make sure when you have an inequality that you are always reading the variable first. So hopefully these slides and this video has made sense. If you have any additional concerns or questions, feel free to email me. And I hope you enjoyed the video and I hope you have a great day. Thanks.